All right. Hi, Daniel.
Hello, everyone. Hey, Adam. Thanks for having me here.
Thank you so much for joining us. And yeah, thank you for everyone else for bearing with us for minor technical difficulties here. I think that's responsibility is all on me. Yeah, so today I'm really, really excited to have a special guest with us, Daniel. Daniel is the man behind Rock the JVM. So it's pretty exciting for me personally to have you on here. If I remember before Zymposium existed, probably before I even started contributing to ZO, there was Rock the JVM and there were these cool courses. And so it's very cool to kind of go from just being kind of the voice in the course to getting to talk to you. So that's really cool. It looks
Same
like you got
here.
is that a Snowball blue microphone there?
Yes, it's a blue snowball microphone. I've been using it for ages, and yeah, nobody complained about the audio quality yet, so I'm gonna keep it for a while.
Very, very cool. I used to actually know the people who worked at that company. So that's a neat
Oh,
story.
amazing.
Yeah. Um, so anyway, for everyone here, well, I'll definitely give you a chance to introduce yourself in a second. But I thought there were three things that I was hoping that we could cover, and definitely if you're listening and you're on the Discord, feel free to jump in with other things if I missed anything here. But one is just I want to make sure we get a chance to talk about the Rock the JVM course on ZO 2.0 because I think that's probably like if you wanted this weekend to just do something that's going to kind of take you from zero to like fully operational with ZO2 is probably the best resource out there today. And I want to give us a chance to kind of go beyond just what's on like the website, but like do a little bit of I guess the unboxing or look at that together. And then second, I'd love to get a chance to just get to know you a little bit better and your background and how you got into teaching. And in particular, maybe a little bit like how you think about learning and communicating things. Because I think one of the things you have to do is you have to just like learn about a lot of new topics pretty quickly and get to a point where you can communicate them with other people. And I think that's probably something that everyone has to do a little bit in their jobs. And then third, I'd love to just get your feedback on ZO and ZO2. I think you've got a really good perspective of kind of having a little bit of the beginner's mind, but obviously also being pretty sophisticated yourself and having taught a lot of other people. So that would, I guess, be a big picture of what I would hope we can get through over the next hour or so.
All right, I'm stoked. I'm ready to go wherever you want to direct the conversation.
Awesome. Well, shall we start with the ZO2 course? You want to tell us a little bit about that?
Yeah. So I just made for those for the people watching that have not heard yet, I've launched the ZO 2.0 course, so roughly a couple of weeks after the ZO 2.0 library was launched itself. I have been working on this course ever since ZO 2.0 was kind of like a project. I've been working since last autumn about on the course, and I've been stalking the GitHub repo for a while and tracking all the developments and all the shifts in perspective about the Zero library and the kind of APIs and functionalities that you wanted to offer. And I imbued those every progress in that development. I imbued that in the course itself, which is what I hope to be a very fast learning experience, while at the same time being comfortable for a newcomer to ZO that has never heard of ZO or touched ZO before, that you can learn in a relatively short amount of time. The course is quite long and compact at the same time, so there's a lot of packed information there, but compared to a, let's say, 6 month to a year kind of experience that you would organically get during the job, to learn something like this, my goal at Rock the JVM and this course is to compress that learning time to a couple of days. The committed learner would be able to take this in a weekend, for example.
That's awesome. Do you want to show us a little bit about what's there?
Yes. If you want to, I can share my screen. Let me bring my little development environment and shoot the presentation mode over here. And one moment.
Yeah.
Yeah. And let me go ahead and share my screen. All right, so this is my little IntelliJ project that I've actually shot on camera. So this is one of the things that I do at all my courses at Rock the JVM. I record all code written live, so I make the same mistakes as my students. I mistype, I run into all sorts of trouble, but I try to build everything from scratch so that people understand and empathize with a learning experience, and it shows how I'm willing to go through the same learning process with them as well. So this is everything that I've shot on camera. This is the official Zio course project that you can also find on GitHub if people are interested in checking that out. So the entire code is public.
Wow.
It's all about the progress in the course. And the way that I structure all my courses at Rock the JVM is that I split them into chapters, and every chapter has a different package here in my little course, and every lesson, every independent topic is treated in a separate application with its own examples, with its own exercises. So the way that this course starts is through a recap of the Scala language itself, with the absolute essentials that people should know about Scala before diving into Zio, because you have to be a comfortable Scala programmer before you can dive into Zio, and exploring some concepts that are relevant to this course in greater detail, which is, for example, variance. Variance is a very important piece that is quite abstract and quite obscure, to be honest, in the Scala language, and very few people master that. And it's very, very important that people understand how variance works and the kind of cryptic compiler errors that you can obtain if you don't use variance properly, and to understand all of that before you dive into Zio, because Zio obviously relies a lot on variance. So this is what I do on all my more advanced courses. I go through a recap of the essentials and the very relevant pieces that you will absolutely need in this course. So for Zio, variance is very, very important. Obviously, I also dive into some implicits and givens because I want this course to support both Scala 2 and Scala 3, but it's nothing rocket science. It's variance is much more important for the course. Now, after that, I go through the kind of mental model. So I build upon the essential principles of functional programming and help people understand what an effect is and how to think in terms of effects, with respect to descriptions of computations. So the kind of mental model that you can also obtain from scratch. So almost as if you would write your own Zio from scratch. I know you guys have written your own mini Zios in previous conversations, so I think you know what I'm coming from. And after we, because we do this together in the course, after we establish a solid foundation of what effects are and the essential functional programming principles that we need for the rest of the course, then I introduce the core Zio effect and the core functionalities that Zio will offer. And after that, we build upon the Zio effects to describe some more interesting computations, such as asynchrony and all that good stuff. So in this part 2 package, I describe the effect model and how to think in terms of descriptions of computations, what effects are, how you can identify code that is dealing with effects versus code that is not dealing with effects, and the essential Zio functionalities. And after that, I dive into some more complicated topics around Zio. Obviously, concurrency is one crucial chapter of the core Zio library, and I explore various bits and pieces of this entire chapter because it's quite big. And the core aspect of concurrency is obviously the fiber. And I know more people are familiar with the upcoming JDK changes with Loom and virtual threads and that sort of stuff. But before virtual threads, the concept of virtual thread was quite alien. And this lesson spends quite a bit of time to explain what that virtual thread is and describing the difference between what is natively executable on the computer that runs the programs and the descriptions of the virtual thread, which is essentially the fiber model. And this, again, this is a mental shift that I want to instill in people before we dive into the heavy concurrency in Zio. and explore more complex computations such as racing and all that good stuff. So fibers are the core aspects that will enable concurrency. And then I will dive into parallelism and the resource model, which is quite frankly what gives Zio its pragmatic aspect. So the ability to acquire and release resources regardless of what those resources are and the asynchrony of it. And so putting that aside and programming just in terms of what you can describe regardless of how those things are implemented, this gives Zio its pragmatic outlook. And resources, the resources lesson is very, very important in this chapter. And then built upon fibers and resources and the kind of parallel computations that you can obtain with the ZioFX running at the same time, then we build these more complex lessons such as interruptions and interruptible masks, which are really magical. I mean, the pinpoint interruptible regions, they give a programmer writing ZioFX with interruptions enormous power to design their programs in very minute detail. So this mastering interruptions lesson comes towards the end of the chapter because it's more advanced, and the API is a little bit complex because the phenomenon itself is quite complex. So this part 3 concurrency deals with most of the trouble that we programmers face while using the effect system and describing a bunch of computations that can run in a variety of ways. So not just Zio effects that can be chained and all that good stuff, but also kind of parallel and distributed computations. And after the concurrency package, after the concurrency chapter, I dive into the coordination aspect of it, because once you get into the fiber model and you run concurrent computations, you run into very similar problems to the low-level programmers dealing with threads, such as locking and releasing resources and all that. And some of my students are asking me, why is this different from writing programs in C with lockings and p threads and that sort of stuff, low-level APIs? And the core aspect of it, and this is what gives an effect system such as Zio the magical combination of both low-level and pure functional programming, is the fact that you can deal with these sort of interruptions and with these sort of locking and releasing and solving the classical computer science problems with pure functional programming. So you're describing how the program works, but then when you click run, it's only then that the effect starts executing in the way that you've designed it beforehand. So this is why I've dealt with refs and promises, which are the two fundamental concurrency primitives. And then upon those two, you can build a lot more complicated concurrency primitives, such as a mutex or cyclic barriers or countdown latches and all that good stuff. I'm only dealing with a mutex because even implementing a mutex in purely functional terms is quite involved. So I walk people through all the steps that are necessary to deal with all possible situations with a concurrency primitive, such as interruptions, managing those, maintaining pure functional programming and returning effects every time, and all that, and so on and so forth. And obviously, I will explore some of the core concurrency primitives that Zio offers, such as semaphores and also STMs, which is what this transactional effects lesson is all about. So transactional effects is I think it's a 1 hour lesson. I think it's more than that, with STMs and describing why STMs are different kinds of effects than Zios and what advantages you can find using those. And at the end of the course, I explore a testing chapter with all the testing functionalities that Zio can offer, with some essential test services, the built-in test services which can replace the built-in ones, some property-based testing, compatibility with JUnit if you want to run it in a development environment like IntelliJ, and so on and so forth. So in total, we write more than, I think it's 3,000 lines of code in a couple of days, which is quite compact and if you want to solve the exercise yourself, you would probably end up with a little bit more than that. So this is a brief overview of what the course offers. I hope I was clear enough.
Yeah, that was fantastic. And I think you can see from this like the benefit of having that like ordered, structured approach, because I think a lot of these are things where like, I think you're right. Like we've done like a session on like refs, we've done a session on STM. I think there are other resources you can go to get like any one of these specific things. But I think you've done an amazing job here of taking all of this and putting it together into one integrated offering that's going to take you from one of those things to another in a very logical and structured way with the exercises and with everything else along with that.
Yeah, that's the goal. That's the goal of the course. The goal is all in the structuring of the topics involved, so that you only learn what is necessary and the core foundation that you can carry with you. So the core principles, and then a sequencing. So the sequencing is super important. The sequencing of topics is key, because this is what gives people a sense of progress. And as a learner, I know how important it is for me, and I try to empathize with people learning a complicated tool, that they need something like this, and this is what I try to provide in a course like this.
Yeah. As you were putting it together, were there any particular areas where you found yourself thinking about different ways of structuring things? Like one thing I noticed here is it looked like you introduced the environment type pretty early, which I think can definitely make sense. I've seen other people kind of defer it. I think we've probably been moving more towards introducing it early, but were there any things that you kind of struggled with as you were thinking about what the right ordering of this was?
I did a lot of experiments. So before I could record the course, which is the final bit of everything, the most of the work is in experiments and different kind of examples and structuring and sequences and exercises and different ways of picturing
Yeah.
certain topics. And I've done a lot of experiments, and what I found for uh, for myself as a learner, and through my experience as a teacher, is that uh, the environment is indeed semi-deferred. So I don't dive into the environment thing very early. The environment thing is only introduced with respect to the original IO data type. So I introduce the concept of an effect with a zero lambda unsafe run that just executes whatever you want to put through it. And only when I introduce the zero data type, I know that when you introduce the zero data type, it has 3 type arguments. So it's only natural for people to ask what those type arguments are. And so I then go back to the old IO data type and add the extra type arguments and describe what they mean. So the environment is sort of like the argument to the function that you will execute at a later point. And the error and desirable value type, obviously, they're more understandable. So it's only through that sort of mapping to the data type that they implemented themselves earlier that they can then relate to the native data types of Zio. So to your point, the environment data type is a little bit harder to understand when you see Zio for the first time, but with the groundwork that we've put in earlier, it's much easier to relate to, because when you implement your own data type, you know what you were thinking when you were writing it. And therefore, it's easier to infer or to understand the necessity of adding those type arguments. And similarly with other, but there are a million problems that I faced with this course, with respect to concurrency, with respect to racing and APIs that would link to each other, and they were quite hard to destructure. And that's natural. I mean, every single topic that I've taught at Rock the JVM had this property, because if it were easy, everybody would learn it, and there would be no need for Rock the JVM, actually.
Yeah, absolutely. Are there any of these sections that maybe you'd like to open up and go through a little bit so that people can get a better idea of what it looks like when they do one of these?
All right, so I can walk you through some lessons that I've added here. So some of the groundwork that I was talking about a minute earlier is the effects lesson, where I describe what functional programming is in terms of referential transparency and the kind of local reasoning that we can expect. And I go from like step by step from a plain expression that can be reduced to the value that it evaluates to more complex computations such as IOs and options and more complicated data types that are harder to relate to. But because they are very popular in regular Scala world, such as options, they're more easily relatable. So we say that, for example, we say that an option is or the way that people learn what an option is, it's kind of like a mini collection with at most one item in it. This is how people relate to options comparing to lists. But then the immediate question that arises is, why on earth do we need a collection with at most one item? Why can't we just use a list? And then you start to get into the more philosophical aspect of an option, which is the possibility of an absent value, which eliminates the need for null checking. And this leads to more elegant code. And this leads to more freedom in how we think and approach code so that we don't need to write defensive code all the time. So that when you start to get into the more philosophical aspect of a data type like this, you then understand what pure functional programming is all about by piecing together different examples like this, like options and tries and futures, and giving some discrepancies between them. For example, I run through what I call an effect checklist, which is, so the effect properties here. So I run through an effect checklist. So I define what an effect is supposed to be, and I run some very known data types in Scala, such as option, try, future, and that sort of stuff, and walk them through the effect checklist. And for example, an option is an effect because it satisfies all the checklists. And the effect properties include the fact that the type signature must describe what the computation is supposed to do, the kind of value that it will produce once it's evaluated, and if the side effects are required, if there is a separation between the construction of the effect and the execution of that effect. So those two things must be separate. In the case of option, that is the case, but in the case of future is not, because when you build a future, then the entire mechanism for allocating a thread and all that good stuff is triggered. So there's no separation about that, and because there's no separation, the future is not an effect in this definition. And so I walk people through this kind of intuitive notion of what an effect is supposed to be. Obviously, there's probably a probably more rigorous way to define what an effect is supposed to be. But at this stage, when you're barely a comfortable Scala developer, you don't want, or at least I found in my experience teaching, the students don't really want a complete theory of what an effect is supposed to be, like a 13-hour course about what an effect is supposed to be, and then dive into the practical aspects. I'd rather introduce an intuitive but slightly like 99% correct model, and then fill in the necessary gaps. So this is one of the things that I've come to add into my Rock the JVM courses that arise naturally from the progress there. Because the tools are complex, and because the tools are complex, you can't really design a completely linear progress like this and this and this, because otherwise everybody would write like a 12-step tutorial to mastering anything, and we would be done with learning. We wouldn't need to learn anything. And so because the tools are complex and various pieces relate to each other, untangling them and designing a sequence that's not frustrating and at the same time not boring was the main goal for this course.
And so when people are watching the video of this, like this effects file would start out as basically being a blank file, just like
yes, exactly. I create
effects,
the file,
and then
so
as you watched it, all of this
yeah. So
out in the
essentially,
video.
what the course starts with is that this entire thing, this entire piece, except the playground thing, starts at nothing. So it's exactly like this with a playground. We go with a playground file with a hello world, and then I build everything from scratch. So all the packages, all the files, everything from scratch.
Your code looks very clean and well organized for being built
Right.
up on video.
I know, right? With a single file, everything is well organized.
Well, I actually know the other one too, but that's fantastic.
Yeah. So
yeah.
this is the kind of approach that I try to that I try to take in this course. And so far, it's been quite well received. People have completed the course already, and they say they quite liked it and it clicked in their mind, which is 100% my goal. So if it clicks and if you say like aha
Yeah.
at least once, that is mission accomplished for me.
And so in terms of like exercises, is the goal that then like I would kind of redo that section that we looked at, or is there a separate like set of exercises that I would work through there? How does that work?
So the way that a regular lesson goes is that I walk through some examples that I run on camera. So I talk and I write and explain, I make mistakes, I correct and modify the same code. So I have some progress. I show some progress on the actual examples that I'm writing. And then probably in the middle of the lesson, I try to keep it like 50-50. I give some exercises. I ask people to pause the video. And then during that pause, students would ideally work through the exercises themselves and try to find out solutions and on that good stuff. If I'm doing my job right, maybe 10% of the exercises are a little bit difficult, which is good. And then I will come back, unpause the video, and then I would show some suggested solutions. Obviously, there are a lot of potential solutions to the same exercises, and people have suggested improvements to the solutions that I give, which is great. But I would show my solutions on camera, so no exercise would be left unanswered, no question would be left in the void.
That's really cool. So like maybe if we go back to that one before, like what would be like some of the
So
like things
in
that would
the
be left for
effects
the users?
lesson, I would have, let's say
Oh, there
we
you go.
have an
Yeah.
exercises section. I would have these written on camera and explain what the exercise means. So create some IOs, which measure the current time of the system, measure the duration of a computation, all that. Some easy exercises because this is an early lesson in the course. After I've defined a really simple data type that passes all the entire effect checklist. And once I've defined that, I then explain the philosophy of it, which means any sort of computation that might perform side effects. And then once we have that, let's start using that. Let's start to imagine some sort of programs that we can build with that. Let's imagine some easy programs, like how to measure the duration of computation, how to read something from the console, how to, well, whatever. And so I would have, let's say, solutions. So I would, of course, these things are written on camera as well. Of course, when the exercises are written, I write them and I explain what they mean. And obviously there is no code. I ask people to pause the video, and then I go through the exercises step by step and explain why I've approached them in this way.
Awesome. So I've been getting lots of comments from people who say they love Rock the JVM and how can they, where can they do this? And so I've added the link to our Discord here. So yeah, everyone definitely check that out. And I also got a question of, can we expect to see any other Zio courses in the future?
Yeah, so I'm at the moment I'm building. The goal of Rock the JVM is to essentially cover the entire Scala space, and for Zio in particular, I would like to have some sort of bigger project that people would start from scratch, something like they would really deploy to their own my little website .whatever.com. So something that they would use. And this is my goal for Zio as well. So ideally, I would cover the core, the most important libraries in the Zio ecosystem, such as Zio streams and the things that stand out in the Zio ecosystem. I know there are dozens of them now. So I would cover that. And I would cover a project that would be a little wider in scope. So not just the Zio core library, but also some effects, maybe some HTTP, maybe some data processing, maybe, I don't know, something along these lines. Obviously I haven't built that yet. I've just released the course 3 weeks ago. But
what do you mean? You don't already have the next one?
Yeah. So there's probably going to be some time and some experimentation involved, because with everything that I'm doing, there's a lot of behind the scenes work and a lot of broken code. And the project that you've seen so well organized, I have dozens of them that are not so well organized. So yeah, I do intend to to cover Zio in a wider scope with some kind of like real life project that people can build from scratch. The goal of this course is to give you all the essential tools to work with the Zio core library and just master it and just read any code that has Zio in it. And in the future, I'm probably going to do something more project based.
That sounds really awesome. Yeah, we had another Zio contributor, Olive, who did this like Zio pet clinic project, which I think is a little bit going in that direction of, I mean, it's still kind of simple, but you know, does the HTTP, it does persistence, and you kind of put all that together. But it's probably another thing where there's like just a GitHub for that right now. But boy, it would be great if people had something that would like walk them through beginning to end doing that. And like you were
Yeah,
talking
because
about, you actually
the
see
whole
the
point of something like this
things.
is to teach people how to think, not necessarily how to like copy and paste some project and click it works. Not obviously we've done our fair share of Stack Overflow copy and pasting. We're engineers, for God's sakes, but it's best for a learner, including myself, especially myself, to walk through the kind of mental process that's involved in a project like this. So why did you approach XYZ? How did you think of structuring your code in this way? What's the architectural cost of doing this instead of that, and so on and so forth. So this is what I want to add in a course like this, not just how typing, just type with me and everything will be fine. I don't want that kind of process. I want to get people inside my head and to be able to share my thought process in approaching this project.
And that's also part of what you get when you do one of these courses, right? There's like a community, and you can
Yes.
interact with other people around the content versus just kind of you've got it and go off and do your own thing with it.
Mm-hmm.
That's awesome. So I think that's maybe a great transition to. I think there were a bunch of people who were just interested in your own background and how did you even get into this at all, and what's it been like essentially building this brand and thing you've created?
Well, I'm a software engineer like everyone else, so I come from the trenches. I know what it's like. My background is in computer science and is in software engineering. I'm based in Bucharest, Romania. This is where I'm speaking from right now, and I've started teaching. I think it's 8-9 years ago, something like that, 2013. Yeah, that's about right. And I started teaching object-oriented programming in Java, and then a friend of mine introduced me to Scala, and they had some unusually large eyes when they talked to me about Scala. They were like this, like, Daniel, let me show you. Scala is like this and this, and they were talking about these abstractions that you can build, and I was like, dude, what are you talking about? And say, dude, just watch. And I would start diving into Scala, and it was very mathematically approachable to me because I also have some physics background. Before I started computer science, I used to go to these physics competitions, and the kind of abstractions that you can build with Scala and the kind of mental model that was instilled into the language itself appealed to me like nothing else. And so I started devoting some more time to Scala in my spare time while I was, well, essentially nobody in Romania was writing Scala. And I would learn Scala through my own little projects, and I would teach Scala to some enthusiastic soon-to-be software engineers in university in summer schools. I have some pictures with them with a T-shirt that says "Cool story, but can you Scala?" or something like that. I would continue to teach Scala to some few but very passionate people about these kinds of mental models that I just discovered. And after that there was a little break from active teaching, but I was working in Scala for my own projects in the meantime. I worked at Palantir a while back, and I would sneakily introduce some Scala in there. There is probably a data pipeline that's written in Scala that nobody understands, that's probably running as we speak. And I would, and when I left Palantir, then I decided to give Scala and teaching, so to combine these two interests of mine into this Rock the JVM project, which has grown beautifully over time. And people have responded quite well. I'm quite surprised. I'm constantly amazed by the kind of comments that I receive, and I want to thank people for doing that. I couldn't be here without their support and without their feedback.
And so if I just rewind for a minute, how did you get interested in teaching in the first place? Because you could be a software developer and just do your thing, and
Yeah,
you
yeah, exactly.
never go beyond that. So what
Yeah.
got you motivated for that?
I think I have a few moments that clicked for me. I was in a workshop teaching the observer pattern. I remember it very vividly. In Java, I was teaching the observer pattern, and I described the observer pattern. I was talking for like 20 minutes, and I was writing things on the whiteboard and drawing diagrams and all and everything. And when I finished the exact last sentence of what I wanted to speak about the observer pattern, somebody in the room, I remember her very vividly, just lit up, just like aha. And that phase just clicked for me, in the sense that something said in my mind, you should do this more often. You should teach more often. You should teach more. And in time, there were more events like this, more lit up faces like this. And this inspired me to do this sort of teaching. And because I come from the trenches and I know what it's like to learn a complex tool and grappling with documentation and scouring old blog posts and old videos and things that don't work, and 5-year-old GitHub repos that have their dependencies all blown out of the water. I know what it's like to not be able to learn the thing that is appealing to you. And I wanted to break these sort of barriers for people, because I know also what it's like to have your face lit up when somebody gives you the right sequence and the right progress for the topic that you want to learn. And so I want to create these sort of feelings for people, more than just transfer some hard 2 + 2 = 4 and APIs and everything that they can also find online. I want to give people a shift in mental models and give people a new way of thinking and approaching code, and these sort of aha moments as many and as often as I possibly can. And this is what I want to do with Rock the JVM. Obviously, this sort of teaching philosophy and teaching inspiration combined with a passion for the Scala language, and this merged into what is now Rock the JVM.
That's an amazing accomplishment. Beyond, so it sounds like that idea of kind of focus on the aha moments and on building people up versus just giving them answers is part of it. What else do you think have been the things that have helped you be successful with this? Because I don't think there are a lot of other resources of the quality and breadth of this in the Scala language.
Well, I don't think it's impossible to make resources like this. I think what allowed me to build these materials is like I said, a combination of interest, pure curiosity for the Scala language itself, so for the domain that I want to teach, and also a sort of empathy for students. So this kind of empathetic approach to teaching informed every material that I've made, even everything, all the blog posts, all the YouTube videos, all the courses, all the talks that I've held, even the conversation that we're having right now. Everything is informed and inspired by this intrinsic curiosity and desire to give people this sort of curiosity that I also had, because curiosity can also be trained and it can be instilled. So it's not necessary. I don't believe it's, at least in the great part, I think it's trainable. And so this is what helped me build these materials, and whether they're good quality or not, I let people talk about it. It's something that I try to talk to people about. So I launch it, and then people respond, this is good and this is not, and this is what you should add and this is what you should remove, this is what was confusing for me, and so on and so forth. And over many iterations, this came to be what is now my teaching style, and the whole Rock the JVM materials.
Well, there are a bunch of people right now who are commenting they've had a lot of those aha moments in your courses.
I am the most happy. This is what makes my day. Every single comment that I read over email, over Twitter, over anything, and I'm going to, yeah, if we're rocking the JVM, okay. So every single comment that I read about these aha moments, or how the Rock the JVM materials help people in their careers, this makes my day every time. Everything else can go down the toilet. If I have something like this, it makes my day. And there are many days like this. Many people don't know about my my regular days of work, but there are many days where I can't get anything done because all my experiments failed, and it's part of the process.
What's your strategy when you're trying to learn a new topic? And maybe what advice would you have for other people who have to learn something new? And maybe there's not a Rock to the JVM video for this yet.
Let me know, and I'll make a Rock the JVM course. I'm kidding. The way that I learn a thing that interests me is that I open a million tabs, reading everything that I can on the topic, without the requirement or without the mental pressure that I put on myself for it to make sense. So I read a lot of crap until some pieces start to maybe get close together. And when they start getting close together, then I invest more effort into those. Maybe they make a connection, and so on and so forth. So I think my learning process is a little bit chaotic, which is how all learning processes are supposed to be when you don't have a predefined learning curve in school, or in some sort of course, or something like that. And it's messy, and I grapple with it all the time. And I think the general pressure that I put on myself is that I constantly ask myself, when is this going to make sense? When am I going to know it with a capital K? When am I going to be good at it with a capital G? You know what I mean? And suppressing that pressure is kind of mentally and emotionally hard. And it always pays off, because eventually things will make sense. If you're putting enough time and enough mental energy and effort into this, it's going to make sense. Now, I do have an approach for how to not read or how to not learn just randomly, but I do have to expect that things are going to be messy, especially at the beginning. So I follow three things when I learn. First, I want to deconstruct what the topic that I want to learn is all about. So I want to understand the pieces of it, and that is in itself a messy process. Then after I've deconstructed and I've identified all the pieces I try to find out which are the most important, because there's always a Pareto kind of distribution with everything, including learning. And I try to find those very few critical pieces that will get me the furthest, the quickest. So I try to get more insight into those. And if I can find a sequencing or kind of a dependence between these topics, I try to mentally traverse the graph and follow these topics until they make sense. So it's not necessarily 100% random thing when I try to learn something. I try to deconstruct. I try to select the most important pieces of the thing that I want to learn, and I try to find the dependency or the connections between these components so that I can mentally traverse a graph and construct a loose mental model of what that thing is about. And then I can obviously read random stuff because all the random bits will click into what I've already built. So this is how I build a mental model about what I learn. And this is what built Rock the JVM in from the very beginning. I learned Scala in this way. I learned Zio in this way. I learned Spark in this way. So yeah.
You're getting all the puzzle pieces on the table first and just
I
letting
try. It's
sitting with the
always
uncomfortableness
feasible.
of it,
Yeah.
and then you kind of try to put them together in the right way.
Yeah. This is essentially the process. Now it's not an infallible process. In fact, it's very, very fallible, and you're only going to get 80% of the pieces out there because not everything is completely apparent. You're going to get 80% of the connections right. You're going to get some connections wrong, but it simplifies the learning process a lot compared to just reading randomly.
And then once you feel like you understand that, how do you think about effectively developing a strategy to teach that to someone else?
So part of my learning process is at this point it's quite built into me, but it wasn't that way for a long time. But I try to learn a topic or a piece of a topic in the style that, or the goal of learning a topic is supposed to be to explain to someone else. So if I'm learning something, such as, let's say if I'm learning Zio, if I'm learning Zio fibers, I want to read about Zio fibers until I can convincingly explain to someone else that has never seen fibers in their life what a fiber is, and then they'll be good to go. So part of learning is also my intention to teach it in some sort, because I do believe that you're not able to teach until you've fully understood, or if you've understood it at least, let's say, 10 times better than the person that you're talking to. And with yeah, a big part of learning is my intention to explain it to somebody, even if that person is eventually real or not. Because conversely, if you can explain to somebody in a convincing way a particular topic, if you can hold like a 15-minute overview of what that topic is, then it is some sort of proof, and it is a sign that you've understood it at least to some fundamental level. Obviously, you can solidify that and so on and so forth. But my goal in learning something is to be able to express it verbally to some fictitious person that I might talk to at a later point.
Yeah, it sounds like it goes back to that idea of depth, of you want to understand what the fiber is and not just how do I get this program to run so it prints these two numbers without waiting.
Yes.
And I think some people maybe start off with, let me just get it to run. And then when they have to explain to someone else, they have to kind of go back, and then they're like, oh, now I really know it. But I think you've just internalized that process. So you do that from the beginning.
Kind of. I don't subscribe to, and I know this might work for some people, the kind of random programs until this works. So trying 100%. some Stack Overflow questions until the program works, and only at a later point do they understand what a fiber is through this sort of experience. But I feel, first of all, I feel frustrated with that sort of thing, because when a program works and I don't understand why, that frustrates the hell out of me, and I don't like that about myself. I don't want to run programs that I can't read or understand. But I know this works for some people. It doesn't work for me, and I can totally understand that.
Yeah, well, I think, you're kind of doing from the beginning the deep, intrinsically motivated learning that I think is, where you always want to be, but sometimes maybe people feel like they can't be, of just, I've got to do this thing for my deliverable and I just need to do that thing. And I think that kind of goes back to your idea about like sitting with the discomfort for a little while of like,
Yes,
this thing's
yes,
not going to
exactly.
work, but I'm just going to figure it out first and then I'll get it to work.
Yes, one of the pushbacks that I hear from to the material that I've put out is, Daniel, but I need to solve the problem. How does this help me solve my problem? I have a 2-hour chapter in the course, but people ask me like, I want this now, and I give people back, you can't have this now. You can have it in 2 hours. It's fine. Not now. Which ties back to your point, which is being able to sit with the potential unknowns and allowing them to fill along the way. The kind of patience that will fill those mental gaps. Because when you're rushing to finish a deliverable, you might stitch together some code and it might even work. But are you actually a better software engineer out of that? I don't know. I am certainly not.
Yeah, yeah. And so if we take some of those same questions and maybe zoom in a little bit on Zio, I think a common challenge people have is maybe they're the advocate for Zio within their organization and they're trying to onboard new engineers. And I think they want to be more productive in doing that. And I guess one answer for them is they should direct new people to do your course. But if for some reason they can't do that or they're just doing it themselves, what would be your advice to them of how they can be more effective in their own internal teaching?
So if you want to learn Zio by yourself, strictly, are you asking strictly related to Zio or any kind of software tool?
I mean, I think I was originally asked about Zio, but I love the answer about both. And yeah, I mean, maybe not even necessarily yourself, but if you're the person, maybe you're the person at your company who's taken the Rock the JVM course. You feel like, okay, I have some understanding. I'm not an expert, but I have some understanding. But I've got 4 other people on my team who've got to get some productivity, and for some reason they can't do the Rock the JVM course themselves right now. But you're trying to just help them build their skills. What advice would you have for that person?
Well, if you a typical experience with a Rock the JVM course is, let's say, a few days. So if people
Yeah.
are onboarding somebody with a Rock the JVM course, which has been my experience with a lot of companies, they walk people through like a 3-day crash session on whatever they need to learn. If you want to learn something like that in a shorter amount of time and be productive, I would say you would probably need to narrow down the things that you can learn in, let's say, if you're targeting a single day. So if you want to be able to read Zio in one day, I would focus on what the Zio core effect is and what it means. Like that's it. Maybe if you want to add in that learning day a little bit of concurrency and some fibers, that's great too. So these 2 things, like Zio and fibers, those will get you the furthest in a single day of learning something like this. Because when you want to compress your learning time, you'd have to cut out most of the ancillary topics in the Zio core library, and you want to focus on the core essentials that will enable you to then learn them at a later point when you have the time, if you have availability. So if you want to deliver something like very, very quickly with Zio, you have no idea what Zio is, you'd probably focus on the core Zio data structure and fibers. I would have these 2 topics and just use those for a day. And with that, you'd probably cover most of the space. So like with everything in learning, there's a Pareto distribution that you can go, that you can apply at many levels. So in Zio, in this course, there are like 30 or so, 40 concepts, lessons. Out of those 40 concepts, maybe 20%, let's say eight lessons will get you most of the results of learning Zio. Fine. Okay. Out of those 8 topics, you may want to learn them in like a day and a half. Maybe you want to practice them for an hour and a half each, so you'd get a day and a half of teaching. If you want to shorten that time yet again, you can do a Pareto distribution yet again on those 8 topics, and you get like 2 topics that are the most important, and that's how you arrive at maybe the Zio data type and fibers. This is what my suggestion is supposed to be. So if you want to compress your learning time, you probably want to do this sort of distribution and find what kind of topics are the most important for you to learn in that short amount of time.
Yeah, and I think that goes back to your idea about depth, because I think sometimes people have less time, like their instinct is just, we'll do everything, but just have less time for everything. And
Of
I think
course.
partly there's like a pressure of like, well, I want to show the fancy stuff with like the concurrency or something. And I think what I'm hearing from you is like, no, like don't do the 15 things shallowly, like pick the two most important things and do them deeply.
Yes, I would recommend that. This is what I would personally do if somebody put a gun to my head and learned like I don't know 2 years ago and learned Zio in one day, I would focus on that. Because those core concepts, especially for a programming library or programming tool, is that when you learn some basic concepts, you don't just learn the API, you learn a mental model. And when you learn the mental model, you can then expand that and extend it to all the functionality that the tool in question is supposed to offer you. So you can then learn the rest of Zio if you have these two topics, let's say, maybe with some ancillary ideas that click with these two, but they enable most of the learning that is important for a library like Zio.
Yeah, yeah. Well, we're almost out of time here, but one thing I would love to ask you is you spent a bunch of time learning and getting into Zio and now teaching it. Are there certain things that you really enjoyed that you said like, oh, this is amazing, chef's kiss, or on the other side, things that you said, this is a little bit painful, this was a bit clunky, these guys haven't totally figured this out yet?
Strictly related to Zio,
Yeah.
I can so I would give Zio the credit for being a very pragmatic library. So you can get a lot done with short code, which is what attracted me to Scala in the first place. This very concise code that is at the same time extremely descriptive and easy to read and understand. So with a library like Zio, I think you can push code that is very, very powerful, very descriptive, and very concise at the same time, which in turn makes you a productive engineer. This is what I think this is the core selling point of Zio, in my view. Some things that I found a little clunky were some type signatures, because Zio has all of these sorts of type arguments, and sometimes the Scala compiler doesn't infer everything, and if you want to keep your code descriptive and or compilable, you'd have to add these type signatures, which add a little bit of mental burden. But once you have that out of the way, the compiler then helps you with whatever you need to do. So some of these little things that you might need to add while you're writing some more complex code might put a small mental pressure on keeping track of everything that you wanted to write, because the compiler doesn't do the type inference for you, and therefore you have to keep track of everything that you've written. So this is a small mental pressure, and something that try to remember. Yeah, there was a discussion. I think it was quite close to the Zio 2.0 launch on GitHub, which was the removal of the companion objects with for UIO and everything. I know that was a debate, and I personally would think that adding those companion objects would help in writing code a little bit faster once you know what those types are and what they do. That is my personal preference. I know that's not everybody's personal preference. So I will defer to you, because you're the decision makers of the library. But I found that as a potential bonus.
No, please do not defer to us, because I think you've got a lot of really valuable perspective. I think if anything, there's a danger sometimes of like, we are like so deep into it that my perspective is not necessarily representative of someone who's getting started. And I think you've got a really valuable perspective there. So no, we want to bring all of that together. And I think now I may have to like go through the course and see if I can find some of those type inference issues, because we're always working on improving those. And sometimes it is what it is. And within the limits of this current Scala compiler, we can't do it, but we're always trying to find a way to make it nicer. So yeah, really, really appreciate that. And it looks like Kit is able to join us, at least for the very end. Hey, Kit.
Hi, I made it. Yeah, can we start
Yeah.
again? Sorry. How's it going? Sorry, I just wanted to just hop in. Ignore me, but nice to meet you, Daniel.
Nice to meet you.
Big fan.
Um,
Likewise.
yeah, exactly. I think both of us are big fans of your work here. So I think we're close to wrapping up here. Is there anything else that you wanted to share with folks here? Either, I mean, I think we've talked about the ZO2 program for Rocket JVM, either about that, about teaching or learning in general.
Well, I'm here for people to ask any sort of questions. I try to be as available as possible to everybody that might need me. So if you want to shoot me an email, you can find me at Daniel@RockTheJVM. I answer every single person. I know um, um, the influx of email may be a little high, but it's completely fine. I'm here to help, and I'm more than happy to help assist with any sort of uh, learning related aspect of anything in the Scala world. This is what I'm in for.
Well, I think all of us here appreciate you just being in the Scala world. I think we're excited about this particular program for Zio. And yeah, I think also on your side is you're kind of going through this and you're working with your students. If you see anything that is like, I mean, again, like, hey, it's like felt a little bit less than ideal. I hope you'll always also feel free to reach out to me or the kid or to anyone or open an issue of like, I definitely don't want the attitude to be like, we're the library authors, so like this is the way. I mean, we're like trying to do our best, but we're like trying to take feedback from everyone. So
This is super
definitely, if
important.
you have any, yeah, if you have any, we always want to hear it.
We'll be more than happy to do it.
All right, awesome. Well, thank you again so much for your time. It was fantastic having you here, and I'd really encourage everyone to check out the Rock the JVM. Well, I'll particularly plug the ZO2 Rock the JVM course, but there are many other fantastic courses as well. And I know you've also got a subscription option where I think you get like all of them. So there are like all sorts of ways to like get this great stuff.
Thank you so much. Thank you so much for having me and for giving me the opportunity to talk about the course. I'm more than happy to help if you need anything.
All right, thank you so much. Have a wonderful day and have a
Thank you,
great weekend,
Daniel.
everyone.
Can't wait to watch the recording. All right, bye, everybody.
Yeah, bye.
See you later.